The final term we really need to look at in detail for the start of electricity is resistance. Now, resistance tells us how hard it is for an electron to travel through a component. And if you think about the word resistance in the English language, it kind of makes sense to use it for that kind of thing. So the resistance movement in a war is something that makes it harder for the enemy to win. So it's something that makes something harder to do. So resistance is measured in ohms, okay? Because Ohm is another person, another physicist, who we try to remember by giving him a symbol or a unit. And we write ohms either like that or with this Greek symbol, ohms. So it's measured in ohms. So like speed is measured in meters per second, resistance is measured in ohms. It has the symbol R. So it's another one that has a different symbol to unit, but at least this symbol is very similar to resistance. So R resistance, nice and easy. Increasing the resistance of something means that we're making it harder for the electrons to get through. Okay, so if we increase the resistance, we're making it harder for the electrons to get through the component. And if it's harder for them to get through, that's going to slow down the electrons. Okay, so increasing their resistance means we slow down electrons. And we saw a couple of videos back that slowing down electrons means we're decreasing the current because less electrons will pass a point in 1 second. So an ammeter would count a lower current. So increasing the resistance decreases the current because it's making it harder to get through. Now, if we look at our simple circuit diagram here, I have my cell, I have my wires, and I have a resistor. Now, a resistor is just something that makes it harder for electricity to get through, and they're there to control current and to do lots of other useful things. If we look at this circuit, we see wires. Now, people always think, oh, wires are really thin wires. Well, that's what they are. They must be really hard for electrons to get through. Actually, they're not. Wires are pretty easy for electrons to travel through. So that means we can kind of say they have zero resistance. They don't really think about it. It's kind of like you walking along a road. It's not difficult. Or walking along a really wide corridor in school. So it's got zero resistance basically. And it's like a really wide corridor. So if you think about 100 of you trying to get through this corridor, it's quite easy. It doesn't really take much energy up. A resistor is harder to get through than that, and that is why it's a resistor, okay? Any component will provide resistance. So lamps, motors, things like that, they all provide resistance. Resistors are just things that are specifically done to do that and nothing else. A lamp provides resistance whilst giving out light. Now, a resistor is hard to travel through. So it's kind of like, thinking about the nice walking along a road analogy, it's like walking now through a swampy kind of boggy place, or walking through treacle I often think about. So a resistor is hard to travel through. If we think about our corridor analogy, that means it's like a really narrow corridor. So if you think about 100 people trying to travel through this or this, obviously this one will be much easier, this will be much harder. So the resistance of this resistor is much higher than the resistance in a wire. Now, increasing resistance is like making it harder for you to get through that. So if I increase the resistance, it's like making that corridor even narrower, if I can even do that. There we go. Decreasing resistance is like making it wider. And that should say resistance, not resistor. Or think about it in terms of the toffee bog kind of analogy. Increasing resistance is like making the toffee or the bog that you're walking through even harder to walk through, so even more muddy, even more sticky. Now, resistors heat up as a current flows through them. This is really important because they often ask about this in exams. Resistors heat up as a current flows through them. Why that is something that it's important that you understand. Now, we said before that a conductor is something that electricity can travel through quite easily. Resistors are still conductors because resistors, the electrons need to get through them. They just have to find it a bit more difficult to get through them. They can't be an insulator because then it would stop and that would break the circuit. So, a resistor is still made of usually positive ions in a nice regular shape with a sea of localised electrons. It's just harder for them to get through. But the electrons, when they're travelling for electricity, so like here, they need to get through this lattice of positive ions. So that's why they need to travel through there. Now you can imagine there's loads and loads of electrons going through, and there's these big ions in the way because electrons are much, much smaller than these ions. There's going to be lots of collisions. So the electrons are going to hit these ions directly. They're not going to go straight through the gaps. They haven't got a mind. They can't try and swerve. They just travel in random directions and they hit these ions. Now every time something hits an ion like this, so a collision causes a bit of heat, causes a rise in temperature. Because the electron transfers some energy to the ion. And that's how heat happens, okay? So when something transfers energy to something else, it can heat it up. So this electron has caused this bit of the wire to heat up a little bit. Another collision will cause it to heat up a bit more. So it kind of carries on. So the collisions cause the resistor to heat up. It's these collisions between electrons and ions that causes the resistor to heat up. And that's exactly how a filament lamp works. So you've probably seen your lamp at home looks a bit like this. It's got a wire that glows in a clear case, not a metal case, I wouldn't be able to see, in a case like this. And this wire is just a resistor, really. And basically, there's so many collisions in this that it gets so hot that it starts to glow. So, resistance is measured in ohms. It's how hard it is for an electron to get through. It's in everything, really, but the resistance of wires is really small, so we don't need to worry about it. And a resistor will heat up as a current flows through it because of the collisions of electrons. They're the 4 main points that we need to know about. So hopefully that video has helped.